today, or second objective for today, is to learn how energy is transferred through the Earth system. So we're on page 151 of your notebook. They are Cornell notes, and your essential question is, how does energy gets transferred through the Earth systems at all time? So we've been talking about transformations, meaning how do they change from one to the other. Now we're going to look at how does it move from one place to another. So we looked at how it changed. Now we're going to look at how it moves. Okay, so transferring just basically talks about how it moves from one place to another. So looking at transformations, what we need to realize is that energy really moves from a high concentration to a low concentration. So the easiest way to think about this is through heat. Okay? So when we think of heat, which is what type of energy? Thermal energy. So when we think of heat, thermal energy always moves from areas of warmth to cool areas. It always goes from hot to cold. And you know that. Because at one time or another, you have gotten cold, and whenever you get cold, and if there's a fire, are you going to try and move towards the fire?
Yeah.
Yeah. And that fire is hot, but you're getting warmed up because you're cold, the fire is hot, so the reason that you're able to warm up is because the heat from the fire is going to move to the cooler area, which is you. And that's what warms you up, is because you're cool and the fire is hot. Now, there are three ways that heat energy or thermal energy moves. The first one is the easiest one to think about, conduction. Conduction is the movement of energy, or specifically thermal energy, by direct touch. So if you want to warm up, have you ever been with a group of people and then you kind of get really, really close to them and like your skin is touching their skin and you're trying to kind of huddle? Okay? That's through conduction. You get really cold, you take a blanket, you put the blanket over you. It's through conduction, the actual touch. So conduction is just basically the movement of energy through touch. You have to touch it. So if I have a pot, the only way my pot's going to get hot is if I put it on the stove, correct? It has to touch the stove. That would be through conduction. Okay? The next one is convection, which is what we already have talked about. Remember we talked about convection currents within the earth and in water and air? Basically, convection is that movement of thermal energy through any type of fluid, liquid, gas, okay, anything that flows, in a circular movement called a convection current. Now, why does convection work? What drives convection?
Heat.
Okay, yeah, but why does heat rise and cool sink? Density, very good. So the reason convection works is due to density. The driving force is density. When something is less dense, it rises. When it's more dense, it sinks. So since heat or hot air or hot water is less dense, it rises. Cooler air, cooler water sinks. That's what drives the convection. So an example of convection would be if I get close to the fire, right? And I put my hands, do I have to touch the fire to know that it's hot? No, right? I can feel the heat rising, correct?
Yeah.
The heat rises because of this convection. Because it's warming up the air, and that warm air is moving up because it's less dense. So an example of convection would be the heat rising from a fire. Okay? And then you have radiation. Radiation is thermal energy moving through electromagnetic waves. Radiation is the only type of energy transfer that does not need any matter. Conduction, you need to touch something, you need to touch matter to move. Okay? Convection, you need a fluid, be it a gas or a liquid. Radiation doesn't need matter, because it's a traveling in waves. When we get to the different types of waves, after the START test, you will realize why these are very different than the other ones. Radiation can travel through empty space. That's why we get radiation from the sun. Because the way we get the energy from the sun is through radiation. We wouldn't be able to get it any other way because there's no matter in space, right? So the only way we can get energy from the sun is through radiation, because radiation can travel without any matter whatsoever. Yes, Antonio?
Is it the one that happens most?
Not necessarily. Radiation is what you basically get through light. Any type of light that's coming off, that would be considered radiation. So if I'm talking about that same fire, the heat rising up, that's convection. But the light that comes off of that fire, that light is considered radiation. Okay? Now, it's our major source of energy because that's how we get our energy here from the sun. So that's radiation. Now, that doesn't mean that that's the most common. It's just the one we get the most of because that's how we get our initial source of energy. Okay?
Is it only with the sun, light?
Right, that's a radiation, the light coming off of that light bulb. So any type of light is considered radiation.
But there's different types.
Yes, there's just different types.
So all these three give off heat, right?
Yes. So basically, this is talking about how thermal energy or heat is going to move. Okay? So, when we talk about these, I like talking about conductors and insulators. Because when we talk about thermal energy, it's heat. So you want to think about things that are good conductors of heat that are going to allow this transfer to move very easily, and good insulators which are not going to allow things to move very easily. So what are some good conductors?
Metal.
Metal. So if I look at that periodic table, it fits on the metal side. Would all those be good conductors? Yes. So all metals are good conductors. So what are good insulators? Non-metals. Now give me some examples of some insulators that we use in everyday.
Rubber.
Okay, rubber.
Wood.
What else?
Wood.
Wood. What else?
Plastic.
Plastic. Okay. What are you wearing right now?
Clothing.
Clothing. Cloth. Okay.
What about that stuff for the houses, though? That
The insulation.
insulation?
Yeah. The fiberglass.
Fiberglass?
It's made of fiberglass. Mhm.
So can we put that?
Yeah.
What, fiberglass?
Yeah, it's called fiberglass.
Good.
Which in any case, I mean, glass whatsoever, the styrofoam. So you want to really think about, conductors is easy, metals, you're done. With insulators, you want to think about those things because it's something that they could ask. How can you insulate a specific thing? So, any questions over the notes? So now you have all the information you need to do all your 4 little triangles. So please make sure that you're working on that. Okay, remember it is due next Friday. Okay? Alright, you have about 5 minutes left in class. I would go back and make sure that you have your notebook ready to go if you need to do anything to it.